Hello, grade 8. This is Mrs. Lopez. We are on lesson 7 in our module 1. We are continue to learn about exponential notation, and lesson 7 through 10 is actually a topic C in our module 1, and this is a concluding topic. So we are getting into more depth about exponential notation, calling scientific notation. We are going to start with exploring these large and small numbers, and we are starting with the magnitude. Every number has a magnitude. Can it be big or small? It always means something. It has specific magnitude. So we are going to look at the example first, and then we will see what facts mean. First example. Let M be the world population as of March 23rd, 2013. Approximately, that world population is denoted by M, 7,73,981,143. It has 10 digits, so we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. And therefore, the smallest than any whole number with 11 digits. Smaller than any whole number with 11 digits. The first number with 11 digits is actually 10 trillion. 10 trillion has 11 digits. So 10 trillion we can write in exponential notation is 10 to the 10ths. And that is the smallest power of 10 that will exceed our world population. That is 10 digits, and this one is 11 digits. So the fact 1, the number 10 to the nth for arbitrarily large positive integers n is a big number in the sense that given a number m, no matter how big it is, there is a power of 10 that exceeds m. Any big number can be written with a power of 10, and that power of 10 will exceed that big number. So let's look at example 2. Let M be the U.S. national debt on March 23, 2013. Again, denoted by M, it's this big number. I'm not going to pronounce it to the nearest dollar. So let's look at that national debt, how many digits it has. It says right here it has 14 digits. We can take a look. We have 3, 6, 9, 12, 13, and 14. 14 digits. The largest 14-digit number is this one. The first number that will exceed it, that will be the 14th power of 10, because the 10 to the 14th will give us a 15-digit number. So let's take a look at exercise 1. You will see it looks very confusing, but you will see it's not as confusing as you think it is. This is a big number m, and we need to find the smallest power of 10 that will exceed m. So let's count how many digits this big number has. We have 3, 6, 9, 12, 15. This number has 15 digits. The smallest power of 10 that will exceed this number is going to be 10 to the 15th. Because if I put 10 to the 15th, it will have 15 zeros, and that 1 will make it 16 digits. So if I write 10 to the 15th, it's going to look like this. 1 and 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 zeros and 1 more digit makes it 16. So 10 to the power of 15 will be the first power of 10 that will exceed that 15-digit number. Okay, so we're looking at 15 digits, 15th power of 10. Let's look at exercise 2. Here we have a mixed number. And that mixed number really has 1, 2, 3, 4, 5 digits, because the fraction is the part of that 5-digit number. right? The next number after 1 will be 2, and it's still 5-digit number. The smallest power of 10, so we can write 5 digits. The smallest power of 10 will be 10 to the 5th power, because then it will have 5 zeros and 1 more. So you will get 10-digit number and that, 6-digit number, and that is this first one that you will see that will exceed this number. Okay? All right. So let's take a look at the next one. Let m be a positive number. Explain how to find the smallest power of 10 that will exceed it. Okay, so what we want to do here, we want to look at the number of digits of the number, right? Look at the number of digits that the given number contains. The given number contains. The power of 10 with the same number, the power of 10 with the same number will exceed the given number. The power of 10 with the same number will exceed the given number. For example, let's take a look at number 8. The biggest power of 10 that will exceed 8 is 10 to the first power, because 10 is larger than 8 and it has 2 digits. 8 has 1 digit. 1 digit and the first power of 10. If I look at number 23, the first power of 10 that will exceed this number, because it has 2 digits, will be 10 to the second power. See the relationship? 2 digits, second power of 10. Second power of 10 is 100. It has 3 digits, right? Let's look at number 456. 456 has 3 digits. The biggest power of 10 that will exceed it will be 10 to the third, which is 1,000. 1,000 has 4 digits. Do you see the relationship? So we look at the number of digits the number contains, and the power of 10 with the same number of digits will exceed the given number. Okay? Now let's look at example 3. The average ant weighs about 3 10,000ths grams. Express this number using exponential notation. So let's think about this number. This is a very small number, 3 10,000ths. It's a very small number. We want to express it in exponential notation. So using our knowledge of decimals and fractions, we can rewrite 3 10,000ths written like that into 3 10,000ths written as a fraction. 3 10,000ths we can write as 3 over 10 to the 4th, because 10,000 is 10 to the 4th. 3 over 10 to the 4th. We know that when we have 10 to the 4th on the bottom of the fraction, it means that we can rewrite it as 3 times 1 over 10 to the 4th, which is 3 times 10 to the negative 4th, because this 1 over 10 to the 4th is the same as 10 to the negative 4th. I'm going to do it a little bit heavier for you so you can see that. Okay? Therefore, we can express the weight of an average ant is 3 times 10 to the negative 4th grams. So instead of writing this number like that, and there are much smaller numbers or much bigger numbers, we can just write them using this exponential notation. Okay, later you will find out that it's called scientific notation, but don't even worry about that for now. The chance of you having the same DNA is as another person other than an identical twin is approximately 1 in 10 trillion. 10 trillion is 1 followed by 12 zeros. Given the fraction, express this very small number using negative power of 10. So we look at 1 over 10 trillion. How many zeros does it have? 1. So we have 3, 6, 9, 12, 13, right? 10 trillion, 13 digits. But at the same time, it's 10 to the 13th power. So we can rewrite that as 1 over 10 to the 13th. Okay? Or sorry, 10 to the 12th. 10 to the 12th. Because it's 12 zeros after 10, right? I think they made a mistake here. They put 13. 12 zeros is a trillion, so it should be 13 zeros. I'm sorry. Okay, 13th power. Okay, and that means that it's the same as 10 to the negative 13th. So we can rewrite this number. We don't have to worry about all of these zeros in here. We can just rewrite it in exponential notation as 10 to negative 13th. The power of the 10 is going to give you the magnitude of a number. So when we have negative 13th power of 10, that shows how small the number is. It's a very, very small number. If I look at the previous page at, let's say, this 15-digit number, we have 10 to the 15th, 1 followed by 15 zeros. 15 will show you the magnitude of this number. It shows how big that number is. Okay. Okay. Just wanted to point out to this rule for you, the fact too, the number 10 to the negative nth power, it's a very small number for arbitrarily large positive integers n. So this can be any big number, but when we have a negative number, it's going to be a very small number. We know that is a small number in the sense that given a positive number s, no matter how small it is, there is a negative power of 10 that is smaller than s. So everything that we learned about the positive big numbers, when we have a power of 10 that exceeds the 15-digit number in this case, we also can have the same thing, but for the smaller numbers. We will have a power of 10 that is smaller than the given digit. Okay, so we are going back to our exercise 5 here. The chance of winning a big lottery prize is about 10 to negative 8, and the chance of being struck by lightning in the US in any given year is about 1 millionth. Which do you have a greater chance of experiencing? Explain. Okay, so let's write both of these in our exponential notation. So the prize, the lottery, is 10 to negative 8. And the lightning is 10, and let's count how many zeros. 1, 2, 3, 4, 5, and the 6th place is 1. So negative 6 power. Because negative 6 is a larger number than negative 8, you can have a chance of experiencing lightning strike higher than winning the lottery. So the chance of being struck by lightning is higher than winning the lottery. Isn't that interesting? The chance of getting struck by lightning is greater than winning a lottery. We are going to learn later how we are going to find out how much times it's different, bigger or larger, higher or smaller. But right now we know it's going to be, you will have a higher chance of experiencing lightning strike. Okay. Exercise 6. There are about 100 million smartphones in the US. Your teacher has one smartphone. What share of the US smartphones does your teacher have? Experience your answer using a negative power of 10. So let's look at 10 million. How do I write 100 million? So I have 1, 1, 2, 100, and then million. 1, 2, 3, 4, 5, 6. So I have 10 to what power? First, second, third, fourth, fifth, sixth, seventh, eighth. So I have 10 to the 8th power, right? Because your teacher has one smartphone, they have 1 out of 10 to the 8th power. And if I want to write it as a negative exponent, I will write it as 10 to, using reciprocal, negative 8th. Okay? So the chance of your teacher, what share of the US smartphones does your teacher have? 1 out of 10 to the 8th, 1 out of 100 million is negative 8. 10 to the negative 8. Okay? Here is the problem set. Try to do it at home, and we will go over it in class. Good luck!